Hi everyone, in this short video we're going to how to get started with R. On this window you can see I have a left pane where I have the script and my right pane where I have the console. I've minimized the other panes for environment and plots and help. If I have value 1, I type it and I run, it prints 1. This is the same as me writing print 1. I can go ahead and take a value, say 2, and assign it to an object which I'll call A. When I run it, I will not see the value itself. To see what is contained in the object called A, I will type A and I will run. Some objects, for example pi, have pre-calculated values in them. When we just run pi, you'll get the normal pi to a few decimal places. R is case sensitive, therefore if I type capital P and I run, there will be an error because it will not recognize that object. The common object in R is a vector. You can create them by combining several values. You can do it, for example, by using the concatenate command. When I run, it prints values 1 to 5 in that order. The concatenate command allows you to print in whichever order you want, whichever values you want. The colon will print the values in sequence increasing by 1. You can also use other functions, for example the sequence function, to create a descent in the values. So this one descends from 10 to 1 in steps of 2. Say I have this sequence of values. I don't know how many values will be there. I can use the function called length to tell me how long that vector is. Let's create a vector A again. This vector A has 10 values. So when I print it, you can see the values. I'll create another vector B, which has just 3 values. When I apply addition function with them, or if I try a multiplication with them, I will expect an error. However, when I multiply A by a scalar 5, every value in A is multiplied by 5. I will create another vector C. C has values 1 and 2. A has a length of 10. This time round, when I say A plus C, you notice it works. When I say A times C, it works. When working with vectors, if you want to use mathematical applications on them, it means the length of one vector has to be a factor of the length of the other one, else they must have equal length. I will leave it to you to study how the addition and how the multiplication worked. Vectors by definition have the same type of values. They can be integer. Values 1 to 10 are integers. They can be numeric. For example, when I say values 0.5 and 0.7, when I concatenate them, I get numerics. Numerics are simply real numbers. They can be logical. Logical simply means it's true and false. The true has to be typed in capital and the false has to be typed in capital. An alternative method is to type T and F in capital, which makes them logical. They can be character. Character accept alphanumeric values. Somebody can even add here a character 1. They can also be complex. Another important type of vector is one that is called factor. Notice, first we are concatenating the values yes and no, and then we are using a function called factor to enforce it to be a factor variable. Factor simply means they are categorical. So when we want to view x, we can see that it's a factor and it has two levels, no and yes. The levels are intrinsically ordered alphabetically. When you use the function and class, notice that the levels are taken back to the integer values. The value yes had the value 2, while no had the value 1. When unclassed, the factors can be used for numeric operations. R is case sensitive. You will notice this time round we have 3 factors and yes is appearing twice, with the second one having a capital Y. In the vector function, you specify the class of the vector and how many values you want it to have. We still have these two vectors, A and B. We can concatenate two vectors using the concatenate function. In this case, R will take all the values of A and then add the values of B. In this case, since A and B are both integers, there will be no coercion taking place. However, in the case where somebody introduces two different classes of variables, coercion takes place. More specifically, implicit coercion. Consider D. When we concatenate the vector A with the character yes, we get all the values are implicitly coerced to become characters. When we concatenate a logical and a numeric, the numeric has more weight and the entire vector becomes numeric. When you concatenate logical and character, the whole vector becomes character. One can go ahead and coerce explicitly. Say we have the vector x. The class of the vector x is integer. We can coerce it to become numeric using as.numeric. We can coerce it to character using as.character. However, when you coerce alphanumeric values that are not numbers, what you end up having are NAs. I hope this was a nice introduction. I would recommend you to read a book called R Programming for Data Science by Professor Roger Peng. It is a good starting point for anybody who is new to R. Alternatively, you can also learn from DataCamp. See you in the next video.